Okay, this is another vlog, the School is Easy Director Development series. And Vincent, you and I are going to talk about issues related to Algebra 1. So a part of this series is about helping the directors to understand the issues related to different subjects. Now, we know that you and I have experience, but we also know the directors have experience. So this is going to be a short vlog, about 10 minutes long. And then we're going to have another conversation with our directors and certainly pull information from them. So this is not an indication that we have all the answers and that the directors need to follow everything that we say. This is about starting the conversation. Fair enough? Okay, so let's talk about the issues that come up for students around ninth grade, 8th grade, 9th grade Algebra 1. So let's first talk, what are the typical issues and complaints or concerns that parents share? Because that's the first thing we do. We always try to move them. Even if they're talking about pricing, we're always going to get them back to it. Depends upon what the needs are. Can you tell me more about the issues? So what are the issues that you typically hear about?
Parents, when they're calling for about math in those grades, the specific complaints that they make are often things like the students done well in math in the past, but they're struggling and they don't know why, so that's a big one right there.
Okay, so they don't know why, and maybe things like if we just look at like what are you observing?
What are you observing? Yeah.
You know, if
so
we ask that question,
like they're doing their homework and they understand the homework, but then when they take their test,
they don't test
they're
well.
They're not doing as well
on
as
the
they think
test.
they're gonna do.
Yeah, they might also say that they really are struggling. They're not liking it. They're not having a good time. They hate math. Right? Yeah. It's a struggle at home.
They don't understand their teacher.
Yeah, they don't understand the teacher. Okay.
Or bad teacher, they'll say.
All right, so let's talk about the issues. So one of the things that we want to do with our directors, we want to educate them about some of these issues. Some of our directors are going to come from a teaching, tutoring background, and maybe tutoring math itself and have insight around this, but a lot of them are not going to have this background. So the theme that we're going to kind of come back to over and over again, there's one of the key themes is around metacognition. So metacognition is about thinking about thinking. And so right from the beginning, I want the directors, the viewers of this video, I want you to be thinking about your own experience when you were in school. What were the feelings that you had around math? Were you a good math student? You felt proud about your math experience? Or were you, like a lot of students, not that great at math and took kind of some personal messages on about your intelligence or lack of intelligence, a belief in lack of intelligence? So first of all, I think that that's important. You might even want to pause this if you're listening to it while driving the car or wherever you are. Pause it for a couple of minutes and think about that experience that you had as a student. So Vincent, you had your own experience. I had my experience as well. We might have that another conversation around that in the future. So let's come back to, all right, so we're thinking about this metacognition. If we're talking about the 8th grade, 9th grade transitions, like what's happening for these students, what's likely happening for them as they approach algebra for the first time? What are the kind of issues that all students are confronting here?
You know, algebra is one of those big like math transitions that just requires a sort of qualitative shift, you know. When we go into algebra, moving from the concrete of numbers to the abstraction of variables, or geometry going into this idea of proving theorems and not just taking things for granted, you know, or calculus, thinking about infinity. What's been working for students up until that point, because it's a qualitative change, it's not necessarily going to keep working, and it requires the student to think about things in a different way.
All right. So let's talk about that. You've talked twice about, you used the word qualitative twice. And so I'm going to focus on that for a moment. So there's a difference between qualitative, the not opposite, but if it's not qualitative, we talk about quantitative, right?
Right.
All right. So quantitative would mean is that, hey, a student's doing work, and when they were in kindergarten, they might do a certain amount of work and study. And then when they're in fifth grade, they do more of that. And then the seventh grade, more of that. And so I think what you're getting at is that they hit a point where just more of the same not only is not the answer, but it ends up becoming the problem, because now it leads to frustration, because it's like, not only am I not getting this, but somebody's telling me I'm not enjoying it, and somebody's telling me to do more of this thing that I'm not enjoying and not getting.
Right.
So that really creates a problem. So the qualitative shift. So let's talk about the qualitative shift that's required specifically with Algebra 1. So usually in Algebra 1, they've had some pre-algebra and they've already been introduced to some of these abstractions. But what we're really looking at is this shift. Okay, so the number 3, by the way, is an abstract idea because it's just a symbol that represents 3 things. But we talk about it in concrete things, because most elementary, most students understand that the number 3, they can picture 3 things.
Oh, that's an abstraction too, right? I have a 4-year-old who understands what 4 pens are, but she doesn't understand what the number 4 is, like on its own. So that's its own kind of leap.
So,
right?
All right, that's right. So, but to simplify this conversation so we don't go too deep, we're talking about the number 4, I can see 4 things. Okay. When I have X things, here's the big shift in the abstraction. X things, I can have, 4 things. I can have 10 things. It's a variable. It varies. So I can have 10 things. I have 20. And I can't picture all of those potential things at once. And I think what happens for a lot of students is that because of that shift, they're not making a connection with these letters as really numbers. They're seeing them as letters.
Right.
And so then what's happening is, like when you take in algebra 2x, okay, that means 2 times x. And then when I have 2x plus 3x, I'm supposed to add the coefficients 2 plus 3. So 2x plus 3x is equal to 5x.
Right.
Okay. And then if I say 2x, if I say x to the 2nd power times x to the 5th power, I'm supposed to add the exponents. That's another rule. X to the 2nd times x to the 5th is x to the 7th power. So what we see is that when students get on the wrong track, they're memorizing all of those rules as rules. And there's no connection to the real world, something that they can really understand in physical terms.
Yeah, so when I see the 2x plus 3x, what's going on in their mind is they're like, well, I don't know what x is. So we mean multiply 2 by something I don't know. And so they kind of go into that memorization process. Well, I can just remember to add these numbers together. I don't know why or what that means.
Yeah. And then what complicates this too is that for a student that's struggling with, what am I supposed to do with 2x plus 3x? The easiest, fastest route to solve that problem is tell the student to add the numbers. So 2x, when you see 2x plus 3x, make it equal to 5x, because 2 plus 3 is equal to 5. And that puts out the fire temporarily. So this actually kind of gets into one of the things that I think our directors can begin to understand and to communicate to the potential people that are going to be their customers, the dangers of tutoring and help when it's not done in a way that's thoughtful and metacognitive, right? So when we get to that place, it feels good for the tutor and feels good for the student to have the student be successfully able to add all of these things. 2x plus 3x is 5x, 1x plus 4x is 5x, and 10x plus 2x is 12x. So they get that idea down. This kind of goes to the idea of the puzzle, right? We've talked about the puzzle before. And the puzzle metaphor is that as I'm memorizing things in math, or actually in English or chemistry or biology, when we go through memorization, which is sometimes important, there's a danger. And the danger is that each one of those things I'm memorizing represents a piece of a puzzle. It's actually related to other ideas. But if I just memorize that idea that when I add 2x plus 3x, I'm supposed to add the 2 plus 3. It's like picking up a puzzle piece, and then we put that puzzle piece in another box. We've memorized it, and we can pass that on a test. So what's the danger there, Vincent, in memorizing these puzzle pieces?
Well, eventually, the puzzle has way too many pieces to memorize. It becomes an all-consuming task to try to memorize them.
That's right. Yeah. So we get the, so here's actually one indication that the student's on that the student is in a memorization process, is not really understanding the math, and we need to look for a qualitative shift, is that the math is getting harder as we go.
Yeah.
Right? It's getting harder because there's more and more pieces to memorize. So that's one symptom, is that it's getting harder. The second symptom is the student isn't having very much fun, right? It's not very much fun to memorize puzzle pieces. Those are the two key ideas. The third is that there's not a whole lot of engagement and interaction in a memorization process. It's here's the piece and memorize this and you put this down there. Okay.
Yeah.
The flip
an analogy I'll tell my students, that's kind of like the puzzle piece, is the idea of reading a great story that you're really interested in. And it doesn't take much effort for a student to be able to give you a synopsis and tell you the plot points of what happened. They don't need to study to do that. But if you give them the story written out on note cards for them to sit there and memorize in whatever order, that's going to be a really, really difficult chore for them, and not much fun either.
Yeah.
Because they're not understanding the connections within the story. And the same thing is true for math. Yeah,
that's right. And we're going to talk about that very same issue about writing, engaged writing and engaged reading, as it relates to these same similar or very similar concepts. We'll talk about that in another vlog. A couple more points and then we're going to end this conversation. So we talk about that puzzle and how it relates to the challenges of students in this Algebra 1 class, right? When they're transitioning to algebra, that they don't realize that the thing that they're doing, right, by memorizing these pieces, is not that there's another way. So this is another key concept, is that the student, when we talk about metacognitive, thinking about thinking, or maybe knowing how we know, right, the student is unaware that there's even another possibility. Okay, so one of the shifts when I talk to parents is that there's a process here. We need to immediately, as soon as possible, to build the student's confidence, and we might end up actually picking up some pieces and talking to them about how we're going to work this jigsaw puzzle. We're going to look for some things that look different than the other pieces, right? We're going to look for the corners, and we're going to start to show them, oh, these things go together, and start to get the student engaged. We want to build confidence for the student, and we want to start to show them how this puzzle is put together. But eventually, we want to work towards the student, when they see new puzzles, that they can start engaging with that puzzle and ask the key questions like, are there any pieces that are different than the other pieces? Okay, I see the corners and I see the edges, and start to lay that out, right? And they start to work it. So a couple concepts that we talked about with the memorization: harder, it's not enjoyable. It's harder as we go, not enjoyable, and the student is not understanding. When we start to work the jigsaw puzzle, there's a couple of things to understand. One is that it takes more effort initially, because we don't just have one piece we're memorizing. That's the easiest thing to do, just to memorize one piece and put it down. So we have to overcome that desire to just memorize a piece. But the other issue is, right, we need to get them to start putting the puzzle pieces down and to start to work it. So it takes initially a little bit more effort, but over time, the idea is that the puzzle picture starts to come together. It absolutely gets easier as we go, because if it's a picture of a barn or a lake or whatever, we start getting clues about how these remaining pieces are going to fit. The easiest piece to put in the jigsaw puzzle is
the last piece.
The last piece, yeah. And it's also the most satisfying piece. We put that in, it feels really good. And now we can see the picture. This is the big idea. If we're going to have any purpose in taking these math classes, it's to put the puzzle pieces together. That is going to develop a foundation in math and in science or at language development that actually the student can do something with in the future with this knowledge that they have. And more importantly, when they encounter challenges in the future, they'll know that, oh, wait a second, that's a puzzle, and I have the power to engage with this and ask questions about this and figure out how this goes together and be engaged, and hopefully really enjoy the process as well. Okay, so that's one idea around the algebra. We'll do more on algebra. We're going to cover other subjects as well. Thank you, Vincent, for participating. I will see you next time.